Let's discuss a question on machine design, which is continuation of the common data question. In this question, what is asked is the shear stress in the heavily loaded bolt. Now, for this, what we do is we because this is an eccentric load, so we actually split this into three parts. One is your primary load, which is basically your F by 3 and F by 3 plus your secondary load, which is caused due to the moment. Now the moment here is exactly at the center of B, which is M is P into E, which is 10 into 10 kilonewton. So 10 into eccentricity, which is 150 mm. So let it be PE. Now this movement obviously will try to cause a force F, let's call it P1 showard. So this M causes a force P1 here and causes a force P2 here. Now how do we find out P1 and P2? Now for this there's a simple assumption that the P1 into basically the moment caused by P1 at the center of this is P1 into this length L1, when from the center of the bolt to the mid center, and this length is L2. Now you can see that from the given configuration, P1 plus L1 is the moment caused by the top bolt, and P2 L2 is the moment caused by the bottom bolt at the center. So these two moments are in the same direction. They it's the sum of them has to be the external moment that is applied. I mean, because it is because of the moment M only these are caused. Now how do you find out P1? Because this is one equation which can't give you P1 and P2 in terms of M. Now another set of equation which we use is P1, the ratio when the far away bolt should carry the higher load, that is given by this. So this is kind of an assumption because it's a static indeterminate problem. I mean, it's a simple model which assumes this. Okay, simple eccentric procedure which helps in finding out the load caused by the moment. Okay, so these two, I mean, any number of bolts, the basic set of equations which are used to calculate the shear load due to moment is basically these set of equations. Now in this problem, L1 is basically your 50 mm and L2 is also 50 mm. So it means that P1 and P2 are equal. And so what we can say for this problem is that M is 2, because P1 and P2 are equal, so I just replace P2 as P1 and we get P1. So P1, which is the secondary load, is M by 2L, and let's write M is P into E by 2L, and so P, I mean P in the sense F here, I mean just to make sure we use the same symbol as of the problem. So F into E by 2L. F is basically your F, let's replace it at the end. E is 150 and L is 50. So this is 3F by 2 is the secondary load. And now this load, now let's come back to the figure. Now this load is same here. So secondary P1 and P2 are same. The secondary loads are same. This F by 3 are same. So you can see that the net load on the top bolt is F by 3 at the top due to primary shear load, and you have 3F by 2 at the right side acting rightwards due to the secondary shear load. At the middle you have only F by 3, which we have calculated in the first part, and at the bottom you have the same thing, F by 3 acting downward, and you have 3F by 2 acting towards the left. So A and C both are equally heavily loaded, and we can use either of the thing because the diameter has to be same and the loading is same. So what we do is we use this thing, I mean C, and let's calculate the net load. The net load, obviously you have one is acting in the y direction, other is acting on the right side. The net shear load, because because right angle triangle, so the net shear load you can use to find out the net shear load. Let's do it at the top because of the space constraint. So the net shear load that is coming on the C is F by 3 whole square plus 3F by 2 whole square. And when I substitute the values, it is 10 kilonewton by 3 and 3 by 2 into 10 whole square. So this value along with the square root, this entire value, when you substitute F in the place of F, you substitute 10,000. This value comes out to be 15369.2 newtons. So this is the Newton, and therefore the shear stress, let's do it here. The shear stress will be this 15369.9.2 by pi by 4 8 whole square, because 8 mm load. So this value comes to be 306 Newton per mm square, which is MPa. So 306, answer is B for this. So the only thing is finding out the secondary loads. That is the main thing which we have learned in this. So answer is 306. Thank you.